Okay, excuse me. So now we are, so section 11.2 deals with simplifying radical expressions. So important concepts to remember is what is called the product property of radicals. And that is the square root of a product equals the product of the square roots of the factors. And basically what that means is if you look at the a general equation such as the square root of a times b, that also can be broken up into two different radicals, as in the square root of a times the square root of b. So for example, like here we have the square root of 9x, that also equals the square root of 9 times the square root of x. And as we know, the square root of 9 can be is a perfect square, and that can be written as 3 times the square root of x. So what we're trying to do here is when we solve our expressions, we don't want to have any like decimals in our answers. If we have to keep some of these values as radicals, we must do that, but we can use the product property of radicals to help us get some other solutions here. Like, for example, here A, we have the square root of 18. Now, just the square root of 18 doesn't come out as a it's not a square number, but there are some square numbers that are factors of. So, like, for example, we could take it as the square root of 9 times 2, because 9 times 2 is 18. But 9 can be written as a perfect square, so this could be also equal to like square root of 9 times by the square root of 2. And the square root of 9, as we recall, it was 3, and we can rewrite this expression as 3 times the square root of 2. If we look at B, 36, actually that is a square number. That can be written as 6, but we got x to the 5th. Now, if it's an even number, we can make that into a perfect square exponent. But since we can't, what we can do is make this look like the square root of 36 x to the 4th times by x, which then equals square root of 36 x to the 4th times the square root of x. And this can be written as, the expression can be simplified as 6x squared times by the square root of x. Not too bad. Let's try some other problems. So these examples, they want us to multiply the radicals. So as we multiply the radicals here, let's look at A. We have the square root of 7 times the square root of 7. So if we look at this, this can be written as the square root of 49. And we know that the square root of 49 equals 7. So this is kind of important. So if we were to multiply two radicals that happen to have the same value inside the square root, their answer would be themselves without the square root. Keep that in mind. So if we have the square root of 6x times the square root of 8, this can be written as the square root of 48x squared. And let's try to simplify that. So let's see if there are any values in there that are perfect squares. I think I can get the square root of 16 times 3 times x squared, and 16 the square root of 16 is 4, so then this can be written as 4, and then we got x squared here, so that can be changed as x times by the square root of 3. And as I look at C, I can tell that I can write that as 0, 11, so that can be equaled as 5 times the square root of 44, because 11 times 4 is 44. We got x to the 4th. We got y squared. And we have z to the 6th. And if I look, I can then rewrite this as 5 times the square root. I know that, again, I know that 4 times 11. And then we have x to the 4th, y squared, z to the 6th. And then I can write this as, so the square root of 4 is 2, times that by 5 is 10. Then I can write x squared, y, z to the 3rd, times the square root of 11. And that's the simplified expression here. So that's using the product property of solving radicals. Now let's look at the quotient property. Quotient property states that the square root of a quotient equals the quotient of the square roots of the numerator and the denominator. And if you look here, if you write the square root of a over b is just the same as if you were to write the square root of a divided by the square root of b. And the example of the square root of 25 over 6 can be written just the same as the square root of 25 over the square root of 36, which then equals 5 over 6. One of the things that you have to keep in mind is that when you are solving these, we do not want square roots in the denominator. And what I talked about here with the square root of 7 times the square root of 7, we can eliminate a square root by multiplying both the numerator and denominator by the radical that's in the denominator to get rid of the square root in the denominator. And I'll show you some examples of that later. But first, let's use the quotient property of radicals. So I have the square root of 121 over 9. That can be written the same as the square root of 1 over 21 divided by the square root of 9, which then the square root of 121 is 11, and the square root of 9 is 3. And so now I have the square root of 45 divided by the square root of 5. Now, I don't want to have a square roots in the denominator, so like what I'm going to do is I'm going to first multiply both the numerator and the denominator by the square root of 5. So if I equal this out, that gives me a square root of 225 divided by 5. And the square root of 225 actually gives me 15 divided by 5, and this comes out as 3. Not too bad. And this is what I was talking about rationalizing the denominator. If we cannot have a radical in the denominator, and what I just did in example B is a way of getting rid of that. So let's take a look at A. We have the square root of 16 divided by 7. So that can be written the same as the square root of 16 divided by the square root of 17. And I can say that, or I'm going. Oh, I'm sorry. I'm going to let me erase that equal sign. Okay. So what I'm going to do first is I'm going to multiply both the numerator and the denominator by the square root of 17, which then that equals the square root of 16 times 17 divided by 17, because square root of 17 times the square root of 17 is just 17. And the square root of 16 gives me a 4 times by the square root of 17 all over 17. It's okay to have square roots in the numerator, just not in the denominator. So let's look at b. So b, what I'm going to do first is right off the bat is multiply both the numerator and denominator by the value of the square root in the denominator, which is ab, which then that gives me value of 2 times the square root of ab all over ab. And I can simplify this. I can simplify I can go 2 times the square root of 4 times 2, give me b all over ab, which now I'm going to let me move it over here. Square root of 4 is 2. 2 times 2 is 4, which then leaves me the square root of 2b all over 8b. And I can get 4 over 8 in the lowest terms, as in 1/2. So then that's square root of 2b, and we have b over here, so I can get rid of the 1 and just put the square root of 2b all over 2b. You can leave the 1 if you'd like. I just choose to leave it out. Next thing is let's try to add and subtract radicals. Now, very similar to like adding variables together, you can only add radicals that have the same square root. Like for instance, if we look at example A, I can only add or subtract 12 times the square root of 7 with my 3 times the square root of 7, which then gives me 15 times the square root of 7, and I have a negative 11 minus 15, which this is like writing a 1 right here, which then it would be minus 16 times the square root of 11. And I can't simplify that anymore, so that's how we'll leave it. And if I look at b, at the moment I can't, they don't have anything in common at the moment, but if I look at the square root of 75, I can rewrite this as 3 times square root of 3 plus the square root of 25 times 3, which then 25, the square root of 25 is 5, so now I have 9 square root of 3 plus 5 square root of 3. Now I have a common radical, which happens to be the square root of 3, so now I just take 9 plus 5, which is 14, times by the square root of 3. Last thing here is being able to multiply radical expressions. And for a, I have the square root of 6 times times quantity 4 minus the square root of 24. So I'm going to distribute the square root of 6, which gives me 4 times the square root of 6 minus square root of 6 times the square root of 24 gives me the square root of 144. Which then, see, I can say 4 times the square root of 6 minus, actually the square root of 144 is 12. And that's as much as I can simplify it. For B, it is, I'm going to have to FOIL this. So I'm going to go square root of 2 times the square root of 2, which we know is 2. We have the square root of 2 times by 3 times the square root of 5, which then will be minus 3 times the square root of 10. Then we're gonna, now I got 5, so that'll be plus 5 times the square root of 2, and we got 5 times negative 3 times the square root of 5, which gives me negative 15 times the square root of 5. And as I look at this, I can't see any other way to simplify it anymore, so there's my answer. So that is being able to simplify radical expressions by using the multiplication property of radicals, the quotient property of radicals, and figuring out how to add or subtract radical expressions. I hope this helps. Until next time.